So, we have some new formulas here. If theta is the angle between two non-zero vectors, u and v, where theta is between 0 and 180 inclusive, then these following formulas hold true. They're the same formula, it's just that this one is solved for cosine of theta. See that? They just divided by the magnitude of u and v.
Yeah.
So, same thing, it doesn't matter which one you're using. So, let's see how to... So, I have two vectors, right? And they're at these two locations, and I want to try to figure out the angle in between them. That's what we're going to be able to do with this formula, okay? So, I want the angle, so I'm going to use this formula because it already has cosine of theta by itself. So, up at the top, I need u dot v. That's the dot product, okay? So, if you want to write a note to yourself that that's dot product, that does not mean it's not u times v. It's the dot product, u dot v. Okay, so let's figure out the dot product of our two vectors. So someone tell me how to do that again?
5 times 4.
Yes, multiply the a's together, so 5 times 4 is 20. And then?
Plus 12.
It's going to be negative 36.
12 times.
Right, I multiply the b's together, that's negative 36, and then I'm going to add those two answers.
Negative 16.
Right, so that's my dot product. So far I have cosine of theta equals negative 16 as my numerator.
Oh.
Because that's the dot product.
Now
Now,
find the magnitude.
right, so remember this notation underneath, that's the magnitude of each vector. So, I need the magnitude of this. You might be able to do this in your head. If that's A and B, if it's 5 and 12, what would C have to be?
17. 13.
13! It's a Pythagorean triple, a 5, 12, 13. If you didn't know, if it wasn't a triple, you would just have to do a squared plus b squared and take the square root of it. So that one, particular one, is 13. What is the magnitude of this vector?
3, 4, 5.
Yes, that's a 3, 4, 5, so the magnitude is a 5. So again, if you had to do the math out, do you know the math that you would do? A squared plus b squared, and then take the square root of that answer. Okay, great. So now all I have to do is solve for theta. So I can, right, I can have the calculator do this all at once for me if I want to. Inverse cosine, negative 16 divided by, now I have to do 13 times 5 in the denominator, so I'd have to put that in parentheses. 13 times 5. Okay, there we go. So the angle between those two vectors is approximately 104.3 degrees. 104.3 degrees. All right, you try B without me telling you the answer.
Okay.
I guess I'll leave this up.
Uh-oh. I got one there.
Okay, so everybody
I'm
get,
bored.
huh? Oh,
I just got.
so everybody get an answer?
Yeah. I got 90.
I agree. So this one is a little unique in that when you find the dot product, it ends up being 0. So you actually don't even have to bother with the denominator because you know it's going to be 0 divided by whatever. It's going to be 0 anyway. But if you did do it, that one would be 5. That one is a 3, 4, 5 just multiplied by 2, so it's a 10. So, but I still end up with 0 anyway. But so when who has a cosine of 0? 90, yes. So the angle between those two vectors is 90 degrees.
But if you didn't know that, you can still do second cosine, 0 divided by 50 is get 90.
Right, right. All right, guys, so let's put some of this vector stuff.
So basically,
To
if you
use.
can do that problem, you can do any problem from that last section.
Basically, because some of the problems were just find the magnitude or just find the dot product. The only other thing that I don't think that we talked about today that we did yesterday was the horizontal and vertical components. And those were just these pieces. So that's when I give you the angle and the magnitude, and then you just figure out the A and the B. So it's going the other way around. Instead of me giving you the A and the B, and you finding the magnitude or the angle, it's the other way.
So you give us the magnitude.
Yeah, so for these you get a magnitude and a degree, so then you just pop it into each formula. And that gets you A, and that one will get you B. So again, I'm going to give you all of these formulas, so you don't have to worry about that. All right, so let us put this to use in section 7.5. All right, so first we have another new vocab word, equilibrant. Oh, wait. I'm not sure if I'm saying that right. Equilibrant. Wouldn't there need to be another I? If it was briant.
Or equilibrant.
Equilibrant. Equivalent. Equilibrant. However you want to say it. Okay. Whatever. It's a vector that will counterbalance the resultant. Okay? So remember the resultant. If I take two vectors and I add them together, I had that resultant. We had talked about the tip-to-tail method and the parallelogram method. Either way, it gets you your resultant. Okay? This is, well, so remember yesterday I had the example, you're there and then two dweebs push you. What if you had your friend was like, hey, I'm not going to let you get pushed, so they're holding you back, not letting you get shoved. So your friend would be your equilibrant. So they're not, two people are going to push you, but they're going to hold you back, so you're really not going to move in the end. You follow me?
Okay, so
All right.
offsets the offsets.
Exactly. So, and doesn't it make sense that the magnitude of the equilibrant
It's the opposite. Of
has to be exactly the opposite of the resultant? All right? So, let's take a look at the first example. Equilibrant, that sounds so weird. Doesn't it?
Look up if that's a real thing.
One of you, can you look up this word and how to pronounce it? Equilibrant. 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 Equilibrant? I don't know.
Just ask Siri. You say
Yeah.
you're from New York, right?
I am.
Upstate New York.
Yeah.
My brother's girlfriend is from upstate New York, but she said something really crazy the other day. That was, I couldn't even believe how she pronounced it. It was like garage or something. I don't know what it was.
I would say garage.
Was it like garage? That's my grandparents are from New Hampshire.
I don't know. It was crazy.
Garage.
It was the craziest thing I had heard in a while come out of a person's mouth and tried to be reasonable.
Oh.
Alright, let's hear it.
I don't know what it was. I thought it was garage.
Garage?
Yeah.
I would say garage.
Equilibrant.
Wait, no, I spelled it wrong. Sorry.
I'm sorry to get us out of traffic. My bad.
It's all right. Well, I already did with the pronunciation, but I feel like it's going to come up a lot.
My phone. I have my phone.
Did it tell you?
Yeah, listen, everyone. Shh.
Equilibrant.
Yes.
Equilibrant. Okay.
Wait, no. Oh, that was in the Hindi. That's how you say it in Hindi.
Oh, jeez.
Oh, we are fancy.
There we go. This is English.
Equilibrant. Okay. All right. So we have to figure out the magnitude of the equilibrant. I have two forces, 54 newtons and 42 newtons, acting on a point A. The angle between them is 48. So let's kind of draw this out. So I have one that's 54 newtons. I have another one that's 42, and the angle between them is 98. So I'll make this one a little bit shorter. That one's 42, and this angle is 98. All right. They are now asking me, wait, find the magnitude of the, okay. I have to find two pieces here. So first let's find the magnitude of the equilibrant. Now, remember that's going to be the same thing as the magnitude of the resultant. We did that yesterday. So if I do the parallelogram method, right, here is going to be my resultant, which is going to be the same as the magnitude of my equilibrant. It's just going to go the opposite way, right? So my equilibrant would be this. So this is the resultant. This is the equilibrant. I forget already.
That is the
Equilibrant. All right. So, does anyone remember from yesterday how we found the magnitude of this thing?
Now we have to do like a parallelogram.
Yeah, we're going to use the fact that we kind of created this parallelogram. So, if that's 54, this would be 42, right? Because opposites are the same.
You can't see it.
What?
The back line behind
That
it.
says, yep, equilibrant. All right. And then I also, I'll give you a hint, I had to find this angle right here. Do you remember how we did that?
That plus that is 180.
Right. In a parallelogram, consecutive angles are supplementary. So 180 minus 98 is 82.
Yeah.
And I'm trying to find the length of this. Now, do you remember what to do here? If I'm trying to find that?
Yes, it's law of cosine.
Yes, I use the law of cosines. So x squared would equal a squared plus b squared minus, oh, I'm sorry, b and c, not a and c, a and b. B squared, c squared minus 2 times b times c times the cosine of a.
Formula for this, buddy, don't worry.
Yeah. That's not so bad. And now we just have to solve for x.
And that will get us the opposite of the.
Are we in degrees or radians?
Degrees. All right. Square root of 54 squared, 42 squared.
I can't wait to find the.
I got a crazy high number.
Where do they make those?
I have no idea.
In the room. In the
No, we didn't make that.
42 squared minus.
They went down the street. Yeah.
Oh my god, my back is killing me already.
Did you guys get 63.6?
Nope, I got 4,048.
Did you take the square root though?
Square root of what?
That answer. Because that gets you x squared. You want x, so take the square root of your answer, and we should be in the same spot.
What I end up writing is x equals the square root of all that jib jabber. Just so my eyes.
Oh, you
don't
can,
miss,
yeah.
you know. So x, so now if we want to find the equilibrium, you just have to take the opposite.
Well, the magnitude is an absolute value, so we don't really care.
I got 63.
It would just be, like, instead of being this many east, it'd be that many west.
Okay.
That's all, yeah. But the
So-
magnitude itself is just a number, and you don't have to worry about
We
positive negative.
just found the,
Yes, we just found the magnitude of the equilibrant.
okay.
But now it says, then find the angle between the equilibrant and the 42 Newton force.
We have to find the angle between the, and the 42 Newton degree force.
Yeah, so I'm looking for this angle right here.
Alright.
I'll put a big old theta there.
So we take 63.6.
Yep, so I know that this is 63.6 now.
And we have to find the in between, so it's, I don't know what to do.
It's in our notes.
For example, 2, or is it still here?
Well, you could do what we... Oh, but you would need the dot product. I was going to say, can't we just do this right here? Because I have the two magnitudes, but I don't have the dot product.
The is not enough.
I agree. So then how would you do it?
Mr. Bale.
Law of cosines of required angle. Oh, you do law of sines now.
From the Florida.
Because if I know, oh, okay. All right, that's not so bad. If that's 82, and I know that this is 54, and I know, oh yeah, okay, we can just do law of sines. That's much easier. If I know my resultant now is 63.6, right, and I know these angles, if I know this angle, guys, right here, is everybody looking? If you know this angle,
I can't
don't
see
I
it.
know that? Oh, sorry. If I know this angle right here, don't I know this angle?
They're supplementary.
Right. So if I could just figure this one out. So if I just look at this bottom triangle, look, I can do this over sine of this equals this over sine of this.
Wait, excuse me, can you repeat what you just said?
Yes. Do you agree that if I know this angle, I know this angle?
Yes, because they're supplementary.
Right. So now just looking at this bottom triangle, I can use law of sines. I can do the resultant, 63.6 over the sine of 82 equals 54 over the sine of that missing angle. And that is the only thing I don't know, so I should be able to solve for it. So 63.6 over sine of 82 equals 54 over sine, I'm going to call it alpha because I already have a theta in there. And now all I have to do is solve for that angle.
So the only part of this whole thing that I'm missing is the law of sines.
What do you mean?
I'm just a little rougher on the edges of the law of sines.
Oh, law of sines is, that's going to be a very handy tool to have in your toolbox. Remember that was this one, where it's just the side of a triangle over the sine of its opposite angle is equal to any of the other ones doing the same thing. So I can say, that's how I have it here. The side over its sine of its angle equals side over sine of its angle equals side over sine of its angle. So if I have, I don't need all three of them, I just need 3 of those 4 pieces, and I can solve for that missing one.
So if
you could solve for the other missing angle. Or if I had two angles in one side, I could solve for the one side.
Okay, that's easy enough.
Good. So I have a missing angle this time, so I'm just going to cross multiply. So I would get, I'll write this out if you want, sine of alpha times 63.6 would be the same thing as 54 times the sine of 82. Then I would just divide both sides by 63.6. And then, to get that angle, I would just do second sine. That's it. And then that. Second sine.
Are gonna be crazy on that.
Fun.
Very satisfying.
Yes. $63.6. I get 57.2. So that means that the angle that I'm looking for, theta, is going to be 180 minus that. So I get 122.8. There you go.
That's a tough one, Mississippi. I'm not even gonna lie to you.
Well, it's another good one that puts a whole bunch of pieces of this chapter together.
Yep.
Oh. Oh, man, oh, man.
Okay, are we ready for example 2? I'll take that as a yes. Today is the last day of new material, you know. This is it.
Wow, that's crazy. Can you imagine that, Griffin?
All right, here we go. Find the force required to keep a 2,500-pound car parked on a hill that makes a 12-degree angle with the horizontal. Maybe you go into designing brakes in your future life. I don't know. But if you do, you better be able to do this, because if I park my car on a hill and it rolls, well, that's a problem.
E-brake.
Even your e-brake. You need to know your e-brake needs to be, or your regular brakes need to be able to hold your car without it rolling down a hill. How did someone that designed those brakes, how did they know?
They tried out a bunch of stuff until it worked.
I don't think so.
I do.
Flies on there. What's wrong with that?
As
long as you got the money to fix the car every time it gets damaged, it doesn't work.
Guys, how do they figure out how much support needs to go in a bridge so that all this stuff doesn't collapse? All this stuff goes into it. Yes, I know you're looking at this with, you're only looking at the immediate future. Is this going to help you? I don't know. Is this going to help you, have fun this weekend? Probably not.
Open up.
But in your future life,
Police, we have a warrant.
you may use this. I don't know. All right, so here we go. Let's put some, let's diagram this a little bit. So we have a 2,500-pound car, parked on a hill, 12-degree angle with the horizontal, okay? So that's this angle right here is 12 degrees. Okay? Now, straight down, doesn't gravity act straight down?
9.81.
Well, yes. So this is going to be, I know it's oversimplified, but assuming This is the 2,500-pound force. That's the car is pushing down on the
On
pavement.
that top of that angle, right at that, or is it going straight down?
That's, yeah, this right here is going to be a 2,500-pound force.
It's going right to the core of the curve.
Now, does that matter? Do we need to know that?
Yeah.
Well, it's 2,500. It says it right there in the problem.
All right.
You got it. You're just saying all right.
Well, I'm just confused. What
Look
the
at the
force
form.
would have to do? Are we going to be incorporating this?
No, we're
force?
not incorporating gravity.
We're not incorporating gravity.
No, this is
Like,
all
are we
hypothetical.
incorporating the unit of gravitational force into our problem?
This is all hypothetical.
No.
Okay. Well, that's my point. So it's not like.
Good. Get ready, bro.
Okay.
Do you understand what I'm trying to say?
I think so.
But I don't.
But the force is already, it's already in there, because force is mass times acceleration. So that acceleration's already been accounted for in that
Yeah.
amount, so,
Okay.
yeah, we don't need it. All right, so what we're going to do is we're going to create a parallel line here, parallel to the hill. So basically what we have here, we have a right angle there. I know that I basically created for myself this little right triangle where the hypotenuse is 2,500.
Is that one at the top or right angle?
So this,
No, the other way too. Both ways.
yeah, that would be a right angle.
180 degrees. Like me and the face do that.
Yeah, but you don't work with me. So you can't put that.
Okay, so what's nice about this triangle, it's this top angle is going to be the same as this angle. Because if it was flat, right, I'd be going straight down, but I'm tilted up 12 degrees based on this hill. So this angle right here is also 12 degrees.
Wait, how'd you get 12 degrees for that? Sorry.
It's the same as this angle.
How do you know?
Because if this were flat, these two arrows would be right pointed straight down, right? Right?
I don't know.
This is the force that's stopping my car from moving. This is the force of gravity.
You don't know the force that's stopping it?
I'm trying to figure that out,
Okay.
right? So if it were flat, both of these arrows would line right up on top of each other,
Uh-huh.
right? But I've tilted it up 12 degrees, which means that I've taken that one and I've moved it 12 degrees. Yes.
Got it.
Okay. So all I need to do is find this. That's what I'm looking for. This is the force that's going to stop it from rolling away. So if I'm looking for this, guys, this problem is actually super easy. If you know that this is 12 degrees and you know that that's 2,500, can't you solve for that?
I thought you were solving for.
TOA, opposite over
Force.
adjacent. Tangent. Tangent of x over.
That's the hypotenuse, though.
I'm confused.
It's okay.
I thought we were solving for the other one.
Which other one?
The other line.
12 degree?
The one.
Oh,
yeah,
this?
Yeah, that's what you said you were solving. The force that required to keep a 150, 2,500 pound car. Isn't that the force?
I need to keep it from. So there's, you have the force of gravity, right? And now since I've tilted it up, I don't need to stop the whole, I just need to stop the car from rolling. So I don't need, how do I explain this?
But I thought we were trying to find the force. So I thought we were trying to find the other. What is X in this situation?
That's the force required to stop me from rolling.
I thought that was the other line. What is the other one? The one that, yeah, that one.
That's my force due to gravity. What is this one? So weight is a force whose direction is straight down. So then what's this? I don't know. I don't have an answer for you. I'll ask Mr. Bale. I know. Did it stop right here? Yeah, that's what I started on today. I hope nobody watches these videos.
I literally just watched.
When I need to know how to do these, Vestavia, and it's come down to the wire, and I exhausted all of my resources, these videos are what saved me. So,
Oh,
videos
good.
just-
Well, I'm glad.
I've been
Well,
sitting at my desk
anyway.
before, not knowing how to do any of it, pulled up the video, walked me through the project, boom, had it done in like 45 minutes.
I'll ask Mr. Bale what that is, but I know right now we're just trying to find this.
But I watched the video, now I know what's going on.
So all this is sine. Opposite over hypotenuse. That's it. So sine of 12 times 2500. So I need 519.8 newtons of force to stop this car from rolling away.
I didn't know how to shut it off.
I do. My car was dead this morning. Yeah, I gotta finish up.
Okay, example 3 is kind of the reverse. So they're telling me it's a force of 18 pounds is required to hold a 74-pound crate on a ramp. What angle does the ramp make with the horizontal? So I'm basically looking for this angle in the end, but that angle is going to be the same as this angle. So I'm going to draw my parallel line. Here's my right angle. They're telling me that the force is 18. So this piece right here, that's 18. The crate is 74 pounds. So the straight down part is 74. I'm looking for that angle. How can I find that angle?
Law of, no.
It's not law of, it's just regular old.
74 divided by 18 equals cosine of theta.
Cosine.
It wouldn't be cosine, it's going to be sine, right?
Sine.
Opposite hypotenuse. So sine of theta equals opposite 18 over hypotenuse 74. And now I can just pop that in my calculator and it will tell me. Second sine 18 divided by 74. So that is approximately a 14-degree angle.
Okay. I think that's enough for today. My brain's throbbing from all of the work. I actually have been done so much work already. So,
But we have to finish these 3.
alright. Now, you said it was roughly 14 degrees, right?
Yeah.
Oh, another bearing? Come on.
This is my last week.
You guys are so funny.
Getting a call. Hello?
All right, let's try this one. Last day, guys, of new stuff.
And then we have a test on this. And then we got
Hey, my psych teacher took our last test, our last unit test, and she said, I'm not going to give it to you.
That ain't vibing.
You want this one, though. It's so easy.
doubtful.
Okay, ready? A ship leaves a port on a bearing of 25 degrees. So where's that?
25 degrees would be straight north. Or no, vertical.
Right. So this one's not the north 25 west business. So remember, we had 0 straight ahead of us. So 25 degrees somewhere right about here. Okay. So that's going to be 25 degrees. Ship leaves the port on a bearing of 25, travels 61.4 kilometers. The ship then turns due east and travels, so due east would be this way, and travels 84.6 kilometers. How far is the ship from port?
Now we need to find that angle that goes.
So, I'm trying to find this right here.
Oh, that's just your, resultant.
Uh-huh.
Add a vector.
I do need this angle though. But you know it.
That angle is,
Well, it's whatever the word.
Here's what you could do. Since this is due east, right? And this is north-south.
oh wait.
Let me
you
just
could-
extend
you could do
this.
this though. You could
What?
do 64, you could just do the Pythagorean theorem for this
Yeah,
one.
I know.
I don't have a right triangle.
Yes, you do, if you extend the due east line to the north-south.
Right.
Get a right
So
triangle.
now this is a right triangle, and if that's 25, then I know this one, and then I know that one.
How the heck?
90 minus 25.
So
It's very
65?
faint. It's very faint.
Sorry. I have to do it in pencil though. So that means that this one's what, 115. Now we're in business. And now I can go ahead and do law of cosines.
I'm confused.
What's the matter?
X squared.
She drew a line, made a right triangle so that she could find that angle. Well, done. Next,
How did you find that angle?
we got 65.
That one was 25, right? And now I have this little mini right triangle here.
Okay.
If that's 90, then I know that's 65, right? And then that's just a straight line, so.
115.
It's not drawn straight, it's supposed to be part.
Okay, got it.
All right, so now, this is actually a great question.
So it's x squared equals 61.4 squared plus 84.6 squared minus 2 AB cosine of 1
That's it. Okay, so everybody find the value of x, please.
Find the value of x.
Yep,
You gotta type all that, Johnny.
And then take the square root of all that.
correct.
Oh.
Yeah.
I agree.
Got it?
I got it. Did you all get 123.8? But now, so that's this, 123.8. But there's a second part to this question, ladies and gentlemen. Right. Guys. So you need to figure out, yes, here I would use law of sines. You need to figure out, to find the bearing, wouldn't it be this angle right here? Right? So there it was, and now it's over here. So you need to find this entire angle. We know that's 25. I would use law of sines to solve for this angle right here, and then just add it to the 25. So everybody, please take a moment and find for me this angle right here, and thus the bearing. Guys, I need you to stay with me. I got 15 minutes left.
It's law of sines.
Do it.
It is law signs?
Yes.
So it'd be side angle side.
It's 86 point, 84.
Well, you do the side over the sine of its angle equals the side over the sine of its angle.
Yeah, I got that.
And then solve for the missing piece.
Mine's not like dark like that no more.
The bearing, so here was your port, right? And now the ship's over here.
So just find that angle.
You had to find this whole big angle. But in order to find it, you gotta find this little one. And then add it to 25.
That's not that hard.
No, it's not at all, if you know law of sines.
So that is
And it's a 926.
so would that be 84.6 over sine theta equals x over sine 150.
But you know x. That,
123.
yeah. And then solve for theta.
That's not hard.
Yeah,
Nice bath.
sure.
Good luck in that.
Give me just the bearing is 38.27 degrees. No, plus
Close.
25.
Right, plus 25. So hopefully everybody found out that theta is approximately 38.3.
Oh, I went to the 100.
That's okay. And then add 25 to that to get the bearing. So the bearing is 63.
62 or 63.2.
Yeah. That looks good to me. Okay, there is one left. That's it.
There's 2 left, too.
That's just telling you about airspeed and ground speed. So this involves a plane, okay? So planes fly at a certain airspeed, okay, relative to the air. The ground speed is its speed relative to the ground. Because of the wind, these two speeds are usually different. So there's a difference. So if a plane is flying at, I don't know, 500,
Kilometers per hour.
sure, that's not the same as if it were on the ground driving at 500 kilometers per hour. It could, if there's no wind at all, it would be the same. But usually there's some sort of wind, huh? Okay, so let's see how we can figure this one out. All right, so example 5, we have a small plane. It's following a bearing of 70 degrees at an airspeed of 230 miles per hour. It encounters a wind blowing at 25 miles per hour at a direction of 290. So now I want to figure out, all right, well, where is my plane going, what bearing is it on, and how fast is it going for the, in relation to the ground speed. Okay, so let's start with our plane, and it's going along 70 degrees. Small plane. Okay, so there's my small plane. Oh, geez Louise.
That is a really small plane.
70 degrees, so approximately here-ish. So let me get a north-south line going. This is 70 degrees.
Wouldn't it be 70 degrees from the ground?
No. I'm like, look, this is like an overhead shot of the plane.
Since
Like,
70
I'm above the
degrees
plane
from
looking
the
down.
vertical axis, not the
Right, from the, right.
Gotcha.
230 miles per hour we're going.
That's 199.865 knots.
Wow.
How many ducks does it take to sit a wagon at that speed?
Okay, so I'm going along like this. There's a wind. The wind is blowing 25 miles per hour at 290 degrees. So 290 degrees, right? Here's 0, 90,